friends, welcome back to our channel Concept with Clarity 1. In this lecture, we will try to discuss about the encoders and priority encoder. Okay, so what is an encoder? Encoder is a combinational circuit which has 2 power n inputs and n outputs. So encoder has 2 power n inputs and n outputs, 2 power n into n. Okay, unlike decoder, it has n into 2 power n in n inputs and 2 power n outputs. Your encoder has 2 power n inputs and n outputs. Okay, so unlike the decoder, see the output n outputs are given in such a way that for a specific input the output is defined. Like for suppose if I take a simple 4 to 2 encoder, 1, 2, 3, 4 inputs are there and only 2 outputs are available. Okay, so let us take this as I0, I1, I2 and I3, and let A and B are my outputs. Okay, so the encoder is defined in such a way that the output A and B will be equal to 0, 0 only when I0 is equals to 1 and rest of the inputs are 0, 0. Okay, that means for this particular input condition only the output is defined as 0, 0, and the other inputs like it is 0, 1, 0, 0. When I1 is equals to 1, then the output A and B will be equal to 0, 1, and when I2 is equals to 1 and the rest of the inputs are 0, then the output is 1, 0. Similarly, when the I3 is equals to 1 and the rest of the inputs are 0, then my output will be defined as 1, 1. Okay, what happens when for the other cases, like because there are 2 power n inputs, so I can have many number of combinations, but the output for an encoder is defined for a specific set of input. Okay, only when the input is 0, 1, 000, then the output is 0, 0, 0, 1, 00, then the output is 0, 1. Okay, so for this 4 to 2 encoder, you can see here I have inputs. How many inputs? Equal to 4, that is I0, I1, I2 and I3, correct? And outputs, what are my outputs? Is equals to A and B. Now you can define, you can implement this A and B in the form of a circuit diagram. Okay, you can define the outputs A and B. So A is equals to, you can see here I have A and B equal to 1, 1 in this case. You can see here I2 is equals to 1 and here I3 is equals to 1. Therefore A is equals to I2 plus I3. Similarly, B is equals to, you can see here I have a 1 here, I have a 1 here, that is equals to I1 plus I3. Okay, so the circuit diagram goes like this. I have, this is I2, this is I3, so this will be equal to A output and the same input is given here. This is an OR gate and this is I1. Okay, this is my B input. Okay, so if I connect in this fashion, okay, then I can implement a simple 4 to 2 encoder. Okay, now if you see what about I0 here? What about I0? In this case, you see if my input is equals to 1 and the rest of the inputs are 0, then my output is equals to 0, 0. But there can be another case. What happens to the outputs when the other combination is given? Though when the other combinations apart from this combination is also given, then also the outputs will be equal to 0, 0 only. Okay, that means even if I0 is equals to 1, then also my output will be equal to 0, 0, and that's why the I0 is not shown in this particular circuit diagram, correct? So similarly, I can have an 8 to 3 encoder as well. 8 to 3 encoder as well. You can see here simple diagram. So I will just write the truth table: I0, I1, I2, I3, I4, I5, I6 and I7, and my outputs will be equal to A, B and C. So this is the same thing. So when I have 1 0 0 0 0 0, then my inputs will be equal to 0 0 0. So you can see here the 8 to 3 encoder here. Okay, in the same way you can define the outputs for A, B and C, and you can draw it. So what is the application? So this is the truth table. So you can implement, you can write the equation A is equals to, you can see here, you can write the output equation for A. So this is I4, I5, I6 and I7. I4, I5, I6 and I7. Similarly, B is equals to, this is I2, I3, I6 and I7. I2, I3, I6 and I7. And C is equals to, you can see here, 1, 3, 5, 7. So this is 1, I3, I5 and I7. Okay, so these are the outputs. It can be the application. You see, when I have a processor, okay, so my processor comes with so many IO devices. Okay, we are telling the application of the encoder. Okay, let us take so many IO devices. Okay, IO pins, not devices, it is IO devices and IO pins. Okay, now you see here, for suppose if a processor requires more number of inputs than the available inputs here, then you can see, for suppose if I have an 8 to 3 encoder, you see I have 8 inputs here and only 3 outputs, and these 3 outputs can be given as the input to the processor. Okay, these can be used as the IO pin to the processor. Okay, so I have large number of inputs for a specific set of input. I will be getting the output for an encoder, and that can be directly driven to the processor with the 3 inputs. Okay, so I am saving the number of pins here, number of input pins here, right? So this is the application of the encoder and the design. Okay, so there is another concept called as priority encoder. Okay, now you see here, what is the priority encoder is, here same I shall be taking an 4 to 2 encoder. Okay, 4 to 2 encoder. This is nothing but this is 4 to 2 encoder. Now 1, 2, 3, 4 inputs I have, 2 outputs I have. This is I0, I1, I2 and I3. Okay, now the concept is like this. Here we will be assigning the priorities to the inputs. Okay, so let us take, let I3 has highest priority. That means I3 has the highest priority out of all these inputs like I0, I1, I2. Similarly, I2 has priority than I1 and I2, I1 and I0. I1 has priority than I0. Okay, you see here, that means if I1 is equals to 1, okay, irrespective of the other input, irrespective of I0, then the output will be equal to 0, 1 only. Okay, similarly, if I3 is equals to 1, if I3 is equals to 1, then irrespective of I0, I1 and I2, my output is always equal to 1 1. A and B will be equal to 1 1 only. That is what. Okay, that means we are trying to give the priorities to the inputs. Okay, so you see here this the same thing I will try to explain through and truth table. You see here, this is I0, I1, I2, I3 and A and B are my outputs. If I0 is equals to 1, okay, and the rest of the inputs are 0 0 0, then only I will get input 0 0, output 0 0. Okay, now if I1 is equals to 1, I2 equal to 0, I3 equal to 0. If I1 is equals to 1, irrespective of I0, I get, irrespective of I0 means I0 can be 1 or I0 can be 0. If I1 is equals to 1, okay, because I1 has the priority, more priority than I0, then if I1 is equals to 1, then irrespective of I0, then my output will be equal to 0 1. Similarly, if I2 is equals to 1, I3 is equals to 0, then irrespective of I1 and I0, my output always will be equal to 1 0. If I3 is equals to 1, irrespective of I0, I1 and I2, then the output will be equal to 1 and 1. Okay. Now, you see here, what can we do? What can we do is, we can plot the same thing in the truth table, right? So, we can plot the same thing in the K-map and derive the output equation for A and B. Okay. So, for A, because I have 4 inputs, which K-map I will be using? I will be using a 4 variable K-map. I will be using an 4 variable K-map. Okay. So, here I have I0, I1, I2, I3. Okay. Now, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. Now, you try to plot this thing. So, what is the combination for this one? I have don't care, 1, 0, right? Don't care, 1, 0 means, you see here 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0 and 1, 1, 1, 0. So, 4 combinations for this don't care, right? So, this is 0, 0, 1, 0 means 2, 0, 1, 1, 0 is 6, 1, 0, 1, 0 is 10, 1, 1, 0 is 14. Okay. 2, 6, 10 and 14. Okay. Similarly, you can see here I also have this one. Okay, this one, right? So, what is this? What is this is nothing but, this is, what is this? X, 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 1. Correct? Now, you see here, right from 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, sorry, 0, 1, 0, 1. Okay, 0, 1, 0, 0, 1, 1, 0. Next, sorry, this is 1. This the 4th bit is always equal to 1. Okay, please excuse this one. So, you see here, the 4th bit is always equal to 1. This is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, and the 4th bit is always equal to 1. Correct? Now, you plot these things into the K-map, right? So, you see here, this is equal to 1, 3, 5 and 7, 1, 0, 0, 1 is 9, and this is 1, 0, 1, 1 is 11, 13 and 15. So, this is 1, 3, 5, 7, 9, 11, 13 and 15. Okay. Now, you see the mappings here. So, what is the mapping I have? I have 2 octets. This is octet number 1 and this is octet number 2. Correct? So, I can simply write the combinations here. I0 bar, I1 bar, I0 bar, I1, I1, I0, I1, I0, I1 bar. This will be I2 bar, I3 bar, I2 bar, I3, I2, I3 and I2, I3 bar. Okay. So what is common here? This I0, I1 is completely varying. So here common is I3. Therefore, A is equals to I3 plus. So what is common here? Here I2. I3 plus I2. Correct? Similarly, I can also have the K map for the B output also for B. So what is B here? You can see here. I will draw the K map first of all. A 4 variable K map. So this is I0, I1, I2, I3. I0 bar, I1 bar, I0 bar, I1, I0, I1 and I0, I1 bar. I2 bar, I3 bar, I2 bar, I3, I2, I3 and I2, I3 bar. Okay. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Correct. Now we'll try to write the output equation for B. You see here, this is the combination x100. So this is x100 is 0100 1100. Okay, 0100 is 4. This is 12. This is 4 and this is 12. Correct. And the second one is this one. Again, this combination, I already have the combination here. So it is 1, 3, 5, 7, 9, 11, 13, 15. So 1, 3, 5, 7, 9, 11, 13 and 15. So what is that I get here? Again, what is that I get here is, again I have an octet here and I have a quad. Okay, therefore B is equals to the output equation. This is I3 for octet, and for a quad this is I1 and this is I2 bar. So this is the equation, output equation. Correct. Now we shall draw the circuit diagram for A and B. For A and B, you see what was my A? A is equals to I2 plus I3. I2 plus I3. B is equals to I3 plus I1 I2 bar. Correct. So you see here I can draw like this. Let this be I3, let this be I2. If I add these two, then I get A. Similarly, this is I1 and this is I2 bar. This is given to an AND gate here. This is I1, okay, and I3 is taken from here and given to an OR gate, so such that it will be equal to B. Okay, so this is the implementation of the priority encoder. Okay, priority encoder, right? So I hope you have understood the concept of encoder and how to assign the priorities to the inputs, that is priority encoder. So if you understood the concept, please like the video, share it to your friends and subscribe the channel. Thank you for watching.